Okay, so we're going to look at solving equations in what's called quadratic form. So if I look at an equation like this, it's x to the fourth, x squared, and x0. So if I let y equal x squared, then y squared would be x to the fourth, and I can rewrite this equation as y squared minus 5y plus 4 equals 0. And now I can factor it into x minus 4, y minus 4 and y minus 1. I can check that factorization real quick. Y squared minus y minus 4y plus 4, and that gives me the minus 5y that I'm looking for. Okay, so I have y minus 4 times y minus 1 equals 0. So y minus 4 equals 0 plus 4, and I get that y equals 4. But y is also equal to x squared. So I have x squared equals 4. X equals plus or minus the square root of 4, which is plus or minus 2. Now I take care of the other factor. Y minus 1 equals 0. Add 1 to both sides. I get y equals 1. But y is equal to x squared. So take the square root of both sides. And I get x equals plus or minus 1. So I get 4 solutions, which is not surprising since this is a fourth order equation. I can graph it and check that the solutions are realistic. Okay, let's look at another one. Here we have x to the minus 2 minus x to the minus 1 minus 20. And I'm going to let y equal x to the minus 1. Then y squared would be x to the minus 2, because you square that. Okay, so this equation becomes, putting it right there, that's y squared, that's y minus 20 equals 0. This factors into y minus 5, y plus 4. So real quick check, y squared plus 4y minus 5y is minus 1 minus 20. So that factorization is correct. So I get y minus 5 equals 0 and y plus 4 equals 0. Add 5 to both sides. So y equals 5 and y is equal to x to the minus 1. Well, x to the minus 1 is 1 over x is equal to 5. So I can multiply both sides by x and divide by 5. And on this side it cancels, on that side x cancels, so I get 1/5 equals x. Repeating over here, y equals minus 4, y is x to the minus 1. X to the minus 1 is 1 over x, which is equal to minus 4. And again, multiplying both sides by x and dividing by minus 4. Over there, the 4's cancel. Over here, the x's cancel. And I get that x is equal to 1 over 4, or negative 1/4. So again, use my calculator to check that that the solution works. And one more, x to the 2/3 minus x to the 1/3 minus 6 equals 0. We'll let x equal, or not x, let y equal x to the 1/3. So if I put it in some type of ascending or descending order, I start by choosing the middle one. So y is x to the 1/3. I square both sides, and so that's going to give me x y squared equals x to the 2/3. So there's y squared, and there's y. So this becomes y squared minus y minus 6 equals 0, which I can factor into y minus 3, y plus 2. So y minus 3 equals 0, y equals 3. Y plus 2 equals 0, y equals minus 2. But y is equal to x to the 1/3. And then we saw yesterday that we can cube both sides, and that gives me that x equals 27. Do that here. X to the 1/3 equals minus 2. Take both sides to the 1/3, or to the 3rd power, cancels the exponents over there, and I get x equals minus 8. So now I need to go to my calculator and graph these to see if both are solutions. But that is quadratic form. Now you notice that these are fractions and these are integers. So if you went to your table or to your graph, you would see that 1/5 is 0.2, 1/4 is 0.25. So you would see in your table that at x equals 0.2, the graph, your table has the y value of 0. So you can convert that to 1/5. You can convert that to 1/4. So if you can, if it works out nicely, you can use your calculator to find the exact answers. If it doesn't work out nicely, you may have to actually do the analysis to get the exact answer.